Welcome to Math with Mrs. Leslie. In this video, we are going to focus on circles, specifically the area and circumference of a circle, and we will also talk, before we even talk there, about the parts of a circle. So here on the screen, you see names such as the radius and the diameter. Let's say the center of the circle is right around here. The diameter is the distance from one side of the circle to the other side of the circle through the center. The radius is half of that. It is from the center to any point on the outside of the circle. So now, no matter where you connect from the outside of the circle to the center, it will always be the radius. And whenever you go across the circle, straight across the circle, through the center, the entire length is called the diameter. It's important to note the relationship between the radius and the diameter, specifically that if I had two radii, which is the plural of radius, if I had two of them, it creates the full diameter. And if I think about it the opposite way, if I take the diameter and I cut it in half, I divide it by 2, it is then the radius. When we go through this, we're going to find both the area and circumference. So it's important to note the area and circumference formulas. The formula for area is pi times the radius squared. In all of our problems, we will focus and keep the radius as the approximation of 3.14. In certain situations, you may have a calculator that has a pi button. If you use the button versus 3.14, your answer could vary slightly. So for our intents and purposes, we are going to stick to 3.14 as the pi approximation that we'll use. The circumference, you will see in one of two versions, either pi times the diameter or 2 pi on 2 times pi times the radius. These formulas are actually one and the same. They are no different. They look different, but they are not different at all. If you ignore the fact that they both have pi in them and just look at the remaining pieces, you will notice that you're left with the diameter in one and 2 times the radius in the other. If you think back to our discussion on the relationship, you'll notice that the diameter is 2 times the radius. Therefore, it does not matter which version of this formula you use. Let's do an example. So, I went a little too far. We're going to come back to this one. In this example, you are given the radius, because you go from the center to the outside, so we know this is the radius. We know that the area formula is 3.14 times the radius squared, so let's plug in. And so we'll plug in 12. We know that 12 squared is 144. And then when we multiply here, 3.14 times our 144 is 452.16. Now, what I've been telling my students is to round to the nearest tenth, so we'll actually do that here. And in that case, the 1 bumps up to a 2, and so your final answer, just to squeeze it in here, is 452.2, and the label is inches squared. Now, that measurement represents the amount of space on the inside of that circle. So if I have a circle with a 12-inch radius, I know that there is 452.2 square inches enclosed within that two-dimensional figure. For circumference, it's the distance around the figure. If I was literally to walk around this circle, or trace this circle, or put a string around this circle, the length of that string, or the amount of space that someone walked, would end up being the circumference. In other words, it's really basically like saying you have the perimeter of a circle. So, if I take the formula, let's say, because this is the radius, 2 times 3.14 times the radius, I end up with 2 times 3.14 times 12. And so in that case, when I multiply, I get 3.14 times all of the other stuff there. And if I round it to the nearest tenth, like we did above, it would be 75.4. Technically, you'll see on your calculator 75.36, but again, rounding to the nearest tenth, you see as shown as 75.4, and in this case, it is inches. It's a distance, so it is just inches for our units. Some may have decided, instead of going this route, to use pi, or 3.14 times the diameter. In that case, 3.14, the diameter of this circle would be 24, because if I double 12, and if you put this into the calculator and round it, you will get the same answer. So in all honesty, you will see that it does not make a difference whether you use the version of the formula for circumference 2 pi times the radius, or pi times the diameter. Let's look at another example. Now this example is a little bit different because of what's given. If you look at the label of this circle now, you will notice that you are given the diameter instead of the radius. And when you go to the area formula, you realize that you need the radius in order to plug into the formula. So we realized from our discussion previously that if we take our diameter and we divide it by 2, we cut it in half, the radius is 6.6 centimeters. Now that we have that 6.6 centimeters for the radius, we can go ahead and use our formula because we have the appropriate information. 3.14 times 6.6, or 6.6 squared. And in that case, at this point I'm going to just work this out, plug this into my calculator, and in that case I get 136.8 centimeters squared. Some of your calculators may have a squaring button where when you put this into the calculator, you can go ahead and literally put in 6.6, hit the squaring button, it automatically does it for you. If you do not, just remember 6.6 squared is 6.6 times 6.6. So you could take your calculator at that point and do 3.14 times 6.6 and multiply by 6.6 again. You would get the same answer rounded to the nearest tenth. Circumference. If we have the diameter, let's use that version. It's a little bit shorter. 3.14 times the diameter, so 3.14 times 13.2. And in that case, once again, we will work that out and then round to the nearest tenth, and we get 41.4 centimeters. Now let's look at a problem that's approached in a slightly different way. So far, we've had a circle with a radius, we found the circumference and the area. We had a circle with the diameter given, we found the area and the circumference. But let's look at this in a little bit of a different way. I have this problem and I say I want to find the radius of a circle that has a circumference of 62.8. So we're going to find the radius of a circle that has a circumference of 62.8. If you think you can go about this problem and maybe have a plan, pause the video, try to solve it, and then restart the video and see if you agree with me. Now, first thing I notice is I'm looking for the radius, but I know the circumference. The circumference formula, we can use either way, 3.14 times the diameter, or 3.14 times 2 times the radius. Let's go about it in the way of looking at it as, let's say, 3.14 times the diameter. Let's go back. So we know that the circumference, this, has to equal this. We're told that in the problem. Our goal is to figure out what the radius is. But realize if we know the diameter, we can find the radius. We talked about that before. If I can find the diameter, I can cut it in half and I'll know the radius right away. So if I want to solve this equation and I want to undo this multiplying here of the 3.14 that's basically in my way, I'll divide. So then, if I take this 62.8 and I divide by 3.14, I end up with 20. So if the diameter is 20, we can automatically cut that in half, and so we know the radius must be 10. So it's a slightly different way of looking at it, although the formulas are still important. We're kind of backtracking through this and going backwards through it to figure out the radius using the circumference. You could also see problems similar to this, dealing with area and things of that nature.